Welcome executives and dummies. Today we are going to talk about embeddings, vector databases, and search. So here are the topics we are going to cover. We are going to understand vector search strategies. We are going to discuss utility of vector databases and discuss differences between vector databases, libraries, and plugins. We'll also discuss best practices for when to use vector stores and improve search retrieval performance. So how exactly do LLMs learn knowledge? There are two primary methods. One is model training or fine-tuning, and the second is through model inputs. Passing context to LLMs helps factual recall. Fine-tuning is usually better suited to teach a model specialized tasks. Passing context as model inputs improve factual recall, and an analogy would be taking an exam with open notes. The downside would be context length limitations. GPT 3.5 Turbo accepts max 4000 tokens as context, whereas Anthropic Claude can accept up to 1000k tokens. Longer context means higher API costs, and it also means longer processing times. So what about vectors? So here is an example, words with vectors. So as you can see, there are different words here in this diagram. Dogs, puppy, car, van, and then they relate with living being, home, transport, and age. And that relationship is captured by a number. So dog has a vector, puppy has a vector, car has a vector, van has a vector. Now we can project these vectors onto two-dimensional to see how they relate graphically. And that's the utility of vector and embeddings. So let's discuss vector database use cases. The key use cases would be similarity search, like text, images, audio. Recommendation engines, for example, Spotify uses vector search to recommend podcasts. A third would be finding security threats, like vectorizing virus binaries and finding anomalies. So here is a diagram which depicts the whole pipeline for search and retrieval augmented generation, also called RAG. So on the left-hand side, top left-hand side, we can see this documents, bunch of documents. It feeds into the language model, and the language model creates embeddings, which is stored in vector databases or libraries. Now then user submits queries to prompts. Language model converts that query to embeddings. Then it consults vector databases to get relevant context or similar documents which are passed as context. And then language model augments and generates completion, that is the user response. So what are different vector search strategies? There are two primary ones. First is k nearest neighbor, and the second is approximate nearest neighbors. In approximate nearest neighbors, there are quite a few examples. And it trades accuracy for speed gains. And the examples of indexing algorithms would be tree-based, for example, Annoy by Spotify, proximity graphs, HNSW, and I think it stands for hierarchical, navigable, small worlds. Then clustering, that is FIS by Facebook, hash LSH, vector compression, and scan by Google. Let's talk about inquiry filtering. Here we compute product similarity and filters simultaneously. As seen in the diagram, it calculates product similarity as vectors. Branding could be a scalar, leverages ANN speed, may hit out of memory issues, especially when the filters are applied, and it's suitable for row-based data. So you have a query vector, right? Like user submits question, and then it goes to the inventory, finds the similar items, and then return the query results. So why are vector databases so hot nowadays? There are quite a few reasons. The primary ones are query time and scalability. Specialized full-fledged databases for unstructured data. They inherit database properties, that is create, read, update, delete. They speed up query search for the closest vectors. They rely on ANN algorithms and organize embeddings into indices. So how do you compare vector libraries or plugins? Many don't support filter queries, for example, where. Libraries create vector indices, approximate nearest neighbor, aka ANN search algorithm, sufficient for small static data, They do not have CRUD support. We need to rebuild. Need to wait for the full import to finish before querying. Stored in memory and no data replication. Plugin provides architectural enhancements. Plugins are generally available for all the big databases or well-known databases. For example, relational databases or search systems may offer vector search plugin. For example, Elasticsearch or pgvector. Less rich functionality generally, fewer metric choices, fewer ANN choices, and it's less user-friendly APIs. So, if you're asking the question, do I need vector databases? Here are some recommendations. The best practice is start without one and scale out as necessary. The pros would be scalability, millions, billions of records, speed, fast query time, low latency, full-fledged database properties. If you use vector libraries, you need to come up with a way to store the objects and do filtering. If data changes frequently, it's cheaper to use an online model to compute embeddings dynamically. The cons would be one more system to learn and integrate, and added cost. Here are some popular vector database comparisons. So the open source ones would be Chroma, Milvus, Quadrant, Redis, VV8, Vespa. Non-open source would be Pinecone. And you can look at the rest of the metrics. Now, if you're asking the question, do I always need a vector store? The answer might be yes if you're building LLM applications. For example, vector store includes databases, libraries, or plugins. Now, vector stores extend LLMs with knowledge. So if your use case or your LLM applications depends on outside knowledge or domain-specific knowledge dataset, then you might need one. The returned relevant documents become the LLM context. Context can reduce hallucinations. Now, which use cases do not need context augmentation? Yeah, so here there'll be kind of three key ones. One is summarization. It doesn't need added context. Text classification doesn't need one, and translation. So the high-level flow looks like the user submits the queries or prompts, language model, it converts the query to embeddings, then it searches the vector databases or libraries, semantic similarity or search, finds the similar document which are passed as context or memory to LLMs, and then it augments and generates the completion, and user receives the response. So vector databases, they improve retrieval performance. This means get better responses. Now, embedding model selection. Do I have the right embedding model for my data? Do my embeddings capture both my documents and queries? Document storage strategy. So the question you should be asking is, should I store the whole document as one or split it into chunks? So here are a few tips. Tip number 1, choose your embedding model wisely. The embedding model should represent both your queries and documents. Now here is a high-level kind of flow diagram. Is your current, or it's a decision tree basically, is your current embedding model trained on similar data as yours? If the answer is yes, then yay, you can keep using that model. If the answer is no, then you have a couple of choices. Choose another pre-trained embedding model, or train or fine-tune your own embedding based on your data. The practice has been around for years in NLP. For example, fine-tune BERT embeddings. Here's the tip number 2. Ensure embedding space is the same for both queries and documents. Use the same embedding model for indexing and query. Or if you use different embedding models, make sure they are trained on similar data. Therefore, produce the same embedding space. For example, the movie data, you consult LLMs, it produces the vector database, it produces the embeddings which are stored in vector databases. It will give you bad result if the user asks questions about medical literature, and you can see why. Now, chunking strategies. The question is, should I split my docs? So chunking strategies on a high level determines how relevant is the context to the prompt. How much context chunks can I fit within the model's token limit? Do I need to pass this output to the next LLM? And then the splitting one doc into smaller doc. One doc can produce n vectors of m tokens. So as you can see in the diagram, the documents are split into chunks, 1A, 1A, 1B, 8A, 8B. It gets fed into LLMs and it produces the vector space. And the similar documents are clustered together. Chunking best practices are not yet well defined. It's still a very new field. You can look at these resources: text splitters by LangChain, blog post on semantic search by Vespa, light mention of chunking, and then chunking strategies by Pinecone. I'll highly recommend text splitters by LangChain. So here is our overall summary. Vector stores are useful when you need context augmentation. Vector search is all about calculating vector similarities or distances. Vector database is regular database with out-of-the-box search capabilities. Vector database are useful if you need database properties, have big data, or need low latency. Select the right embedding model for your data. Iterate upon document splitting or chunking strategy.